guys, I want to review some pretty challenging concepts within pulmonary ventilation, specifically talking about gas laws. So I have a quick tutorial. Hopefully this will help as you are working on your lessons. So the first thing you want to remember is that our cavity within where the lungs are or the serosa is made up of the parietal pleural serous membrane and the visceral membrane, and that's going to create a cavity where your lungs will be housed within here. So now based on that, so just something to know, the dynamics of those membranes will actually create a difference in pressure within that cavity in comparison to that outside. So outside or within the atmosphere, we tend to have slightly higher pressure, right? And then within that cavity of our lungs, we have a slightly lower pressure. So that's just normal, okay? Now, how this helps, right? So as a result of having these pressure differences, and something else to note is that kind of like diffusion, you may have learned about diffusion where particles tend to go from a higher concentration to a lower concentration. Well, sort of going based on that idea, well, gases in areas of higher pressure will tend to move naturally toward areas of lower pressure. You can think about it as like these gases are kind of moving all over the place, and when you have a high pressure, it usually is due to the fact that you have a much smaller space and they're kind of like bouncing into each other. So when you have a bunch of gases in an area of high pressure, it means that the space is actually smaller. So that gets into Boyle's law a little bit. So if we decrease the space, the pressure actually increases. And so that makes the molecules like, hey, wait a minute, I got to get out of here, right? And so they're going to try to seek an area of lower pressure, right? And oftentimes an area of lower pressure coincidentally is also an area of much bigger volume. So there's more space for them to kind of jump around and do their gassy kinds of movements. All right, so those are some basic chemistry behind gas laws. So let's get back to our anatomy here. So looking at some of the muscles of inhalation. So there are two primary muscles of inhalation. We have our diaphragm, which sits at the base of our rib cage, and here I have a little demo. So kind of like this, right? So here would be your diaphragm, and this would be your outer serous membrane, the parietal pleura, and then the inner serous membrane would be the balloon inside of here, and then your lungs would be housed within, okay? Now, if I increase the volume or increase the space by pushing my diaphragm down, so here's a diaphragm, if I push the diaphragm down, right, take a look at what happens, right? It pulls, it creates less pressure, right? Increase volume, increase the space, it decreases the pressure, and then it causes the gas molecules to want to go in there. So we're trying to fill the space that we just lost, okay? All right, so what'll happen here is that when I pull down on the diaphragm, I'm increasing the volume, decreasing the pressure, so then the area in the atmosphere, the pressures are already slightly higher. It's just going to want to go into that space and fill our lungs up even more, okay? So we decrease that pressure, right, by increasing the volume. So we increase volume by moving the diaphragm down and making more space within our thoracic cavity. It decreases the pressure, which causes a bigger change in the pressure difference between the atmosphere and within our lungs, which causes the gases in the air to just naturally flow in. All right, so that's one of the muscles. The other muscle that we have involved in normal inhalation is the external intercostals. So these are muscles, so intercostal simply means between the ribs. And so the external intercostals, they'll basically lift the rib cage to make more space outward. So they're kind of like expanding outward, and we're making more space down below. So you've got those two muscles. Now, when we want to exhale, all we do is just kind of like relax the muscles, and then the air will naturally fall out or flow out. And that's because the muscles will just kind of just relax. They'll go back into their normal space, and then it will decrease the volume, which will increase the pressure and force the air outward naturally. Okay? So I hope that was helpful in trying to explain the relationship between gas loss, our muscles, and the flow of gases within our lungs for breathing.